So question number 73, it reads, in a potentiometer experiment, no current passes through the galvanometer for length 52 centimeter, and if the cell is shunted by a resistance of 5 ohm, the balancing length is 40 centimeter. You are asked to calculate the internal resistance of the cell. Now, as we know, the potentiometer is based on the principle that EMF is directly proportional to the balancing length. The potential drop across a particular length is proportional to the potential. Okay, now this is written as E is equal to I rho L. I is the current, rho is the resistance per unit length. It is not, in this case, it is not resistivity, but it is resistance per unit length, and L is the balancing length. Okay, I is the current. So now it is given that for first case, the cell is having, say, EMF is E1. So E or EMF E is proportional to, first case, the length is L1. Okay, when no current is flowing through the galvanometer. Now when current flows through the galvanometer, so that means this case is you're finding the balancing length corresponding to open circuit. When no current is flowing through the galvanometer, that means no current is being drawn from the cell. When current flows through the galvanometer, that means current is also flowing through the cell. So now the potential drop corresponds to the terminal potential difference, and it is written as V is equal to E minus IR, and that is proportional to L2. Okay, so that means E by E minus IR is equal to L1 by L2. Okay, so that is equal to L1 is 52 and L2 is 40. Okay, now this current is equal to E divided by R plus 5. For second case, 5 ohm is the shunt resistance. This is the internal resistance cell, and this is connected with the cell. So total resistance is R plus 5. So if I substitute these values over here, so this is E divided by E minus E by R plus 5 into R is equal to 52 by 40. Okay, so now on simplifying this, you will get R is equal to 1.5 ohm. So for this question number 73, option 1 is the correct answer. So question number 74, code C, the question reads, a telephonic communication service is working at a carrier frequency of 10 gigahertz. Only 10% of it is utilized for transmission. How many telephonic channels can be transmitted simultaneously? Okay, so that means this you have to use, see, 10% of only 10% of it is utilized. That is 10% of 10 gigahertz. 10% of 10 gigahertz is utilized. Okay, so now in this range, suppose you can have n channels, and each channel is having a frequency bandwidth of 5 hertz. So this n into 5 kilohertz. Okay, so that is 10 by 100 into 10 gigahertz is equal to n into 5 kilohertz. Okay, so this, on simplifying, you get n is equal to 2 into 10 power 5. Okay, so this n, we can have 2 into 10 power 5 telephonic channels. So for question number 74, the correct answer is, our correct option is option number 2. So next is question number 75 of paper code C, the physics paper. The question reads that unpolarized light of intensity I passes through an ideal polarizer A. Another identical polarizer B is placed behind A. The intensity of light beyond B is found to be I by 2. Okay. So now the basic concept is, say you have a polarizer A. Okay. Now if unpolarized light is of intensity I is passed through a polarizer, we know that the intensity is reduced to half, so this is I by 2. Okay, now the intensity of light beyond B, so there's another polarizer B. Now here also the intensity is found to be I by 2, so it is given that the intensity of light beyond B is found to be I by 2. Okay, so now another identical polarizer C is placed between A and B. The intensity in this case beyond B is now found to be I by 8. Okay, so now when C is placed, when C is polarized, C is placed between A and B, the intensity beyond B, now it is I by 8. Okay, so you are asked to calculate the angle between A and C. Okay, the angle between the plane of polarization of between A and C. Okay, so now see, this is I by 2. I by 2 is the intensity of light emerging from A. Now that light is incident on C, so from C the intensity is in this side. After C, it is I by 2 cos square theta. Okay, so and now the intensity here, it is I by 8. Okay, so now from this, what is the intensity of light emerging from B? It is I by 2 cos 4 theta, and this is equal to I by 8. That implies cos 4 theta is equal to 1 by 4. Okay, or cos theta is equal to 1 by root 2. So that gives theta is equal to 45 degree. So for question number 75, the correct option is number 2, that is 45 degree. Now question number 76, it reads that on interchanging the resistances, the balance point of the meter bridge shifts to the left by 10 centimeter. The resistance of their series combination is 1 kilo ohm. How much was the resistance on the left slot before interchanging the series? So basically the question says that if you have a meter bridge and so this is R1 and this is R2. Okay, so somewhere this is the balancing length, so this is L and this is 100 minus L. Okay, now the question says that if the series combination of this R1 and R2, it is 1 kilo ohm. Okay, and when these resistances are interchanged, the balancing length shifts by 10 centimeter. Okay, so that means when this is R2 and this is R1, this balancing length shifts by 10 centimeter. So it can shift on either sides. So if I can write this as L minus 10, so this will be 100 minus L plus 10. So it is shifting. Basically, I'm assuming that it is shifting in this direction. Okay, so this is a direct formula based question. You can directly use the Wheatstone bridge principle, and the answer to this question is 550 kilo ohm. You can try this. So the answer to this is 550 kilo ohm, option number 2. So question number 76, the correct answer is option number 2. So next is question number 77. From a circular uniform disc of radius r, mass 9m, a small disc of radius r by 3 is removed. The moment of inertia of the remaining portion is asked. Okay, so basically what you have to do is, see, this is a disc. Okay, so this is a disc of radius r. From this disc, a disc of radius r by 3 is removed. Okay, so now this disc of radius r, it has a mass 9m. Okay, so for disc of radius r, mass is 9m. So that is practically, that means that for disc of radius area pi r square, the mass is 9m. So for a disc of area pi r square by 9, the mass will be m. For this radius is r by 3. For this is radius is r by 3. So that means area will be pi r square by 9. So that is its mass will be m. Okay, so practically what you need to do is you need to find, see, moment of inertia of this whole disc about this point. Okay, then you calculate the moment of inertia of this disc about this point. Okay, then you find the moment of inertia of this disk and subtract the moment of inertia of this smaller disk from this bigger disk. Okay, so if you solve this, you will get I is equal to 4 mr square. So this is the correct answer, moment of inertia of the remaining disk. So for this question number 77, correct option is number 4. This kind of questions is there in your concept of physics by H.C. Verma. You can look into it. Question number 78 is another collision based problem. A particle with initial velocity v0 strikes a stationary particle of same mass. If the final total kinetic energy is 50% greater than the original kinetic energy, the magnitude of relative velocity between the two particles after collision is asked. Okay, so a particle of mass m and it is moving with velocity v0. Okay, and it is undergoing collision with another particle of mass m which is initially at rest. This particle is initially at rest. Now after collision, so this is m is moving with velocity v1 and m2 is moving with velocity v2. Okay, now if the final kinetic energy is 50% greater than the original kinetic energy, that is also given. So that means final kinetic energy is how much? Half m v1 square plus half m v2 square, and it is given that it is 50% greater than the initial kinetic energy. Initial kinetic energy is half m v0 square. 50% greater means 1.5 times, that is 3 by 2 of this half m v0 square. So this can mm cancels out, 2 cancels out, so I can write it as v1 square plus v2 square is equal to 3 by 2 v0 square. Okay, now if you apply principle of conservation of momentum, initial momentum is at rest, so initial momentum is m v0, that is equal to m v1 plus m v2. Okay, so that is v0 is equal to v1 plus v2, or v0 square is equal to v1 plus v2 the whole square. So there is another relation. So you have to use these two relations. Now if you solve these two relations, see, you have to find the relative velocity between the two particles after collision. Now relative velocity of the two particles after collision is how much? v1 minus v2. So from these two, if you have to find the value of v1 minus v2, and this comes out to be root 2 times v0. So for question number 78 of code C, the correct option is option number 1, root 2 v0. Now question number 79 of the code C is again a formula based question. Now as we know that velocity of electromagnetic wave, it is given velocity expression, it is given by velocity is equal to 1 by mu times E, mu into E, square root of this. Now velocity in air, is omega by k. Okay, and omega by that is equal to c. Okay, now velocity in medium, now that according to the data given in the question, it is equal to c by 2. Okay, so that gives, so if you find the ratio of the two, it is 1 by square root of epsilon r1 divided by 1 by square root of epsilon r2, that is equal to c divided by c by 2. Okay, so that is equal to 2. So that gives epsilon r1 by epsilon r2 is equal to, so this is 2, this is 1 by r1, so this is 1 by 4. So for question number 79, the correct option is number 2. Question number 80 reads, for an RLC circuit driven with voltage of amplitude Vm and frequency omega naught, the circuit exhibits resonance. Okay, so this is again direct, you are asked to find the quality factor, right? The expression for quality factor. So we know that quality factor Q, it is given by omega naught L by R, or it is given by 1 by omega naught CR. So in this case it is given in terms of L and R. So the correct option is option number 4. So this is direct formula. Question number 80, option number 4 is the correct answer. So next is question number 81. All the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick the incorrect graph. So in this it is the direct observation. So question number 81, the direct observation says that option number 1 is the wrong graph. So the correct answer for 81 is number 1. So again, this is for code C. Okay, next is question number 82. So basically this question number 82 is a circuit based question. So you have two cells with internal resistance, and this cell combination is connected to an external resistance. Okay, this is cell of EMF 12 volt, internal resistance 1 ohm, this is 13 volt 2 ohm, and this is a 10 ohm external resistor. Okay, so you are asked the voltage across the load resistor range. You have to find the range of the voltage across the load resistor. Okay, so basically in this what you are expected to do is, see, this is a cell combination, parallel cells in parallel. So for this, the equivalent EMF E equivalent, it is E1 R2 plus E2 R1 divided by R1 plus R2. Okay, so this equivalent EMF, this comes out to be around 37 by 3 volt. Okay, equivalent EMF of this combination. R equivalent, this is in parallel, so it is 1 into 2 divided by 1 plus 2, that is equal to 2 by 3 ohm. Okay, so now what is the current in the circuit then? I is equal to, total potential is this 37 by 3. Now this resistance, equivalent resistance, it is in series with this, so this is 10 plus 2 by 3. Okay, so this current is 37 by 32 ampere. Okay, so this is the current flowing through this 10 ohm resistor. So voltage across 10 ohm resistor will be current 37 by 32 into 10. So that is equal to 370 by 32. Now if you simplify it, it is 11.56 volt. 11.56 volt. So 11.56, option 1 is 11.5 and 11.6. So correct option is number 1. So for 82, option 1 is the correct answer. The answer voltage lies between 11.5 and 11.6 volt. Question number 83. The particle is moving in uniform speed in a circular orbit of radius r. Central force proportional to nth power of r. So that means central force F is proportional to r power n. Is inversely proportional to r power minus n. Okay. Now this F is omega square r. So omega square r is proportional to r power minus n. Okay, so that gives omega square proportional to r power minus n minus 1. Okay, so that gives omega proportional to r power minus n minus 1 by 2. Okay, now we were you have to find the expression for time period. Okay, so omega is twice pi by t. Omega is twice pi by t. So that gives, so it is inversely proportional to t. Omega is inversely proportional to t. So that means t is directly proportional to r power n plus 1 divided by 2. So for question number 83, the correct answer should be number 2. Option number 2. Question number 84. If the series limit frequency of Lyman series is VL. Okay, series limit means n final is equal to infinity. Series limit of any series of the hydrogen spectrum is that final n should be equal to infinity. Okay, so this is direct formula based question, like wherein you have to use this h into frequency is equal to E naught times 1 by n1 square minus 1 by n2 square or ni square minus nf square. Okay, so if you substitute these values for Lyman series and Fund series, you can directly solve it, and you will see that the final answer should be option number 3, that is VL equal VL by 25. Okay, so option number for question number 84, option number 3 is the correct answer. This is a direct formula based question. Question number 85. Question number 85, this EMF equation for EMF is given 100 sine 30t. Equation for current is given as 20 sine 30t minus pi by 4. So the phase difference here, it is pi by 4. Okay, and in one cycle the average power consumed, again this is a direct formula based question. P average equal to ERMS IRMS cos phi. Phi is pi by 4. Okay, ERMS is 100 by, this is peak value of EMF, this is E naught, this is I naught. So this is 100 divided by root 2 into 20 divided by root 2 cos 45 degree. Okay, so in one cycle the average power consumed by the circuit, and the wattless current, you have to find the wattless current also. So average power from this you will get is as 1000 divided by root 2 watt. Okay, now wattless current means, see, wattless current, suppose this is the current IRMS, this is ERMS, and this is phi. So if this is IRMS, this will be IRMS cos phi, and this will be IRMS sin phi. Okay, so that means this is the component of current which is perpendicular to this EMF. So that means corresponding to this current, the power consumed will be 0 because it is perpendicular to the EMF. Okay, so that means in this question you are asked to find the value of this IRMS sin phi. So IRMS sin phi means I naught by root 2 sin 45 degree. So that comes to be around 10 ampere. So 10 ampere is the IRMS current for wattless component, and the average power is 1000 by root 2. So option 1 is the correct answer for question number 85. Next is question number 86. Now question number 86 is a question based on thermodynamics. 2 moles of ideal monoatomic gas occupies a volume V at 27 degrees Celsius. The gas expands adiabatically to volume twice V. Calculate the final temperature of the gas and the change in internal energy. Now they basically, see, there is a change in temperature and volume. So temperature volume relation is T V power gamma minus 1, this is equal to constant. Okay, so that means T2 by T1 is equal to V1 by V2 raised to power gamma minus 1. Okay, now for monoatomic gas, gamma is equal to 5 by 3. Okay, so that gives T2 is equal to T1 V1 by V2 5 by 3 minus 1. Okay, this T1 is 300 Kelvin, V1 is V, and V2 is twice V because volume is increased to 2 times. Okay, so this gives, if you solve this, you will get T2 is equal to 189 Kelvin. So this is the final temperature. Then you are asked to calculate 189 Kelvin. There are 2 options, option number 2 and option number 4. So answer is one among these 2. Next is, see, calculate the change in internal energy. See, there is, see, this is a adiabatic process, and there is a expansion. So the internal energy must decrease. Okay, so internal energy must decrease. That means internal energy must be negative. So option 2 should be the correct answer. Okay, option 2, actually it is the correct answer, but let us check it. So delta U is equal to NF by 2R delta T. Okay, so this is 2 moles of gas. So 2 into 3 by 2, monoatomic gas, degree of freedom is 3. So then 25 by 3 into minus 111, that is delta T, that is a change in temperature. So if you solve this, this comes to be around minus 2.7 kilojoule. You need not solve it actually, because anyway there is a in adiabatic expansion there is a decrease in temperature, so internal energy is negative, so it is minus 2.7 kilojoule. So this is the final answer. So option 2 is the correct answer.